here we go. X to the fourth. What's that derivative going to be? So it said find the derivative. So that'd be f prime would be, so close, ready? 4x to the third. You got it. If I were you on this second one, I would rewrite that as something to a power before I do anything. The cube root of x is the same as x to the
1/3.
Yes, thank you, Coop. Then I'm going to say the derivative of that is what? 1/3 comes out front. 1/3 minus 3/3 is negative 2/3. You had it.
Yep.
Boom. You got it. Yeah? Okay, how about this one?
It'd be the same thing.
F prime of t would get me 7/9
X over negative 2/9.
t to the
T to the negative.
negative 2/9. And then, to your point, Coop, if we wanted to move that, it'd be 7/9t to the, that's when we make my exponent positive. What do I do to this guy? Just to get it a variable to an exponent. Right now I've got more than that going on. I got 1 over that. I can't be having any of that. I just need a variable to an exponent. X to the negative 2 is what I started with. Now I can apply the power rule when it's just a variable to an exponent. I could not do it here. What would y prime be? Negative 3. We always take one away from my exponent. Awesome. When I rewrite that, you guys, it'd be negative 2 over x to the positive 3. You don't have to rewrite it, but this might be how AP has it as a multiple choice answer, so we just have to know that they're the same. Q, Q, Q. Whoa. Okay. Ooh, ooh, ooh. How do I... Let's just handle this in the bottom first. What's something square rooted? What's that power?
1/2.
Yeah, so that's the same as 1 over x to the half.
So it's negative.
So it's x to the
Negative.
negative 1/2 makes it in the power rule form, meaning I've got to have a variable to an exponent. That is a very ugly negative 1/2. Let me put that a little nicer. Okay, now we can apply. What is h prime of x going to be now? Ooh, yeah, negative 1/2 minus 1. Negative 1/2 minus 2 halves. Negative 1/2 minus 2 halves? Negative 3 halves. Yup. And we won't be able to have calculators for any of that stuff, so we want to make sure that we're practicing doing that. Kind of thinking it through this way, I think. 1/2 minus 2 halves. I think that'll help us. I said, hey, connect what we know about the derivative. Here's my function, cute little x squared. Woo! Use either limit definition of the derivative to calculate the slope. Whew. Maybe I want us to work backwards, actually. Let's work backwards. Let's go do C first. Let's go C. What is the derivative of x squared? Yeah, so I want you to write that. I want you to say f prime of x is 2x. And you have to do that step before, look what it asks here. Well, what's the slope when x is negative 1? So once we have this, then we can replace every x with a negative 1. What is f prime of negative 1? What is going to happen when I put in a negative 1 right here?
It'd be negative 2.
It's going to be negative 2. So f prime of negative 1. That means the slope when x is negative 1 is negative 2. If I'm looking at an x squared graph, when x is negative 1, does that look like the slope could be a negative 2? It's negative at least, right? My graph is terrible, but it's at least a negative slope. So that's the slope there. This is what we get to do now. I do need to talk you through how we could have gotten there our old long way, which is not fun, but I just want to show you where we came from. So it says use either limit definition. I'm going to remind you we've got two options here. The limit as h approaches 0 of f of x plus h minus f of x all over h. Or we could do the limit as x approaches a of f of x minus f of a all over x minus a. Whew. Let's just choose. Which one would you rather do? In this case, my x is going to be negative 1. So I'd replace this x with a negative 1, or would we replace this a with a negative 1? Which would you rather do? Option black or option blue? Blue. Okay, you guys are in love with option blue. Let's do it. So we're going to say the limit as x approaches -1. I replaced this a with a -1, so I'm going to replace this a with a -1 and that one as well. It is the f of x minus f of -1 all over x minus -1. Because you chose blue, either one would have gotten us the right answer. Okay, so now this limit as x approaches -1. What was my function? What is f of x?
X squared.
Thank you, Cooper. It is x squared. Minus f of -1. When I plug in a -1 there, -1 squared is going to get me 1. So we got x squared minus 1 over x plus 1 was already on the bottom. Hey, Koo, if I put a -1 up here in here, you think I'm going to get 0 over 0?
Yeah.
Yeah. Is there something I could do?
Difference of 2 squares.
Difference of 2 squares. So he says, all right, let's go factor with the plinus. X plus 1, x minus 1. Okay, you guys, what's going to cancel? Oh, boy. What's going to cancel? X plus 1's. Psh. So when I plug in my -1 here, what are we going to get? Oh, my gosh. What you just found with all of this slop was that the slope of this function when x is -1 is -2. Would you rather do all that slop or would you rather use our power rule? Power rule all day, every day. And we get to. I just wanted to let you know it does get us to the same thing. Okay, last thing. We also talked about this. This is a good review of 2.3 and 2.4. Estimate the slope when x is -1 using the average rate of change. You guys, average rate of change, just slope. It's just slope over this interval from -1.1 to -0.9. That is from an x to an x. Those are both x values. That's from an x axis to another point on the x-axis. So how would I find that average rate of change? I need change in y over change in x. How am I going to find my y when x is -1.1? You know it. F of -1.1 is going to be that y. Minus, how am I going to get my other y? Yes, all over. You just did change in y over change in x. -1.1 minus -0.9. Minus 0.81 over -1.1 plus 9. Oh, plus 0.9. That's a problem. Boop, boop. -0.2. Could we end there? Yeah, but I'm just going to do, Bob's definitely going to end there. I love you, Bob. So we know that we would get 1.21 minus 0.81 over -0.2. Guys, guess what? Is my average slope equal to my actual slope? Yeah. So that just happened to work out here. So this is going to get me -2 as well. So have we found 3 ways? Well, this one is just an estimate. Option 2 is just an estimate. This one, it happens to work out great. But both of these help us find the slope, 1 and 3. But 3 is definitely the easiest, so let's do that. All right. So now it says g is the function above. What is the slope when x is 1? But now I've got a piecewise function, and something's going on at 1. It might meet, but it might not. So for something to have a derivative, do you agree it has to be continuous? So for this to be continuous, you guys, the function from the left of 1 better equal the function from the right of 1. Here's how I'd show it. Let's not even talk about the slope yet. The function from the left better equal the function from the right, because if not, it's not continuous, and therefore we cannot have a derivative. So what's g of 1 in the top? So if I'm coming in from the left, 2 minus 2 times 1?
0.
Yeah, and if you want to write that, you can, or you could just say 0. What about plugging in 1 to the bottom?
It'd also be 0.
Yeah, so is it continuous? Yeah, so from the left and the right, they equal each other, so that's good. And we know when x is 1, it's going to be 0. So we know it's continuous. So I'm going to say, all right, we're going to check that box. It couldn't have a derivative, which is what they're asking for, if it wasn't continuous. Now here's what I need us to do. We got to go find the slope now because they want g prime. So we got to go find g prime of x first. Don't you be plugging in a 1 yet. G prime of x. What's the derivative of the top one? Ooh, the derivative of 2. We actually haven't practiced this yet, so I should have not put this question in this, but we can do it. 2 is really 2x to the 0. What's that derivative going to get me?
That'd get you 1.
It'd give you 0x to the -1, but 0 times anything is going to get me. So the derivative of any constant is always 0. Exactly. Y equals a constant. Y equals just a number is a horizontal line. What's the slope of a horizontal line? 0. I love it. So the slope of 2 is 0. What about the slope of -2x? Ooh, the slope of -2x, the derivative of that. Bring that exponent out front. What would that get me? -2x to the 0. Anything to the 0 is 1. So -2 times 1? -2. Does it make sense in y equals mx plus b that the slope was -2? Yeah. What about this one? What's the slope going to be if you just thought of this as y equals mx plus b? Y equals mx plus b. Is my slope going to be 5? The derivative, if I use that power rule, 5x, my 1 times 5 is going to give me 5x to the 0. Anything to the 0 is 1, so this slope is just 5. You guys do my slopes, like you said, Ava, at the beginning of the lesson, from the left of 1 and the beginning of 1, I'm sorry, to the left of 1 and the right of 1, do they equal? No. The slope on the left is -2. The slope on the right is +5. What are we going to have there?
It's
It's a cusp or a corner, and therefore it is not differentiable. Okay, so we're going to say not different. Oh, it just says what is g prime of 1? We're going to say it doesn't exist because the slopes don't equal. So let's practice this guy. Constant rule. The derivative of any constant. So that would be like y equals 6, y equals -4, y equals just a number. A number is a constant. You guys, let's make it like y equals 3 could be our little example. If y equals 3, you're exactly right, Ritzy. That's just a horizontal line. And if I were you, I'd think hoy. And what's the slope of any horizontal line? 0. Boom. Determine the derivative of this. Ready? Let's practice. This 2/6 is just practicing. What's my derivative going to be of that? -32. X to the first, or just x. Okay. Ooh, 100 pi. Does that have an x to a power? It does not. This is just a constant. 100 times 3.14159 is just going to be 0. The derivative of this whole thing, this is just a constant. It's just a number. I'll scare you. That would just get me, if 3.14159 is pi, when you multiply that by 100, just move that decimal over. The derivative of 314 is just going to be 0. Okay, this guy. How could I write this with an x? Oh, yeah. What's this written as an x to a power?
24 or x to 2/3.
Yeah, power over root. Well said. Power over root. When we've got that 2/3, all you've got to do is multiply it by what's in front. And again, we don't have a calculator for this, so we got to practice that. What would 24 times 2/3 be? How I personally like to think about it is divide these first. What's 24 divided by 3? 8 times 2. Got it. We got 16x to the 2/3 minus 3/3, -1/3. How could I rewrite that? Yes. Is that the same as 16 over the cube root of x? Yeah, I think that they'd write it this way or leave it this way. I don't think that they're going to do that, but let's keep it going. Ooh, this one's a little tough. Wouldn't you agree this is my constant?
Yeah.
So it just chills while I bring that 3 out to it.
That would just make it 4 pi.
You're right. So you guys, we would have 4/3 pi times that 3, and Ku is seeing, oh, those 3's are going to cancel. So I'd be left with 4 pi x to the second. -0.75 x to the what right now? To the 1. So bring that out front. What's that going to turn into? Perfect. X to the, oops, I didn't write that right. -0.75 x to the 0. Do I need to write anything to the 0? It's just 1, so I'm not going to. Excellent. Guys, I'm proud of you. Okay, so then all we're going to do to finish up 2/6 is it says, hey, if we need some derivatives, if we've got some function plus another function or minus, you can just take their derivatives individually. And we just keep moving. The derivative of the first one plus or minus the derivative of the second one. So let's practice that. The derivative, so I'm going to name that as y prime since they gave it as y. What's the derivative of x squared going to get me? 2x minus the derivative of 4, a constant. The derivative is just the slope, so we're done. And if you're like, what? Why isn't that following the power rule? It really is. This is really 4x to the 0. 0 times 4 is 0. X to the negative 1. 0 times anything is 0. Yeah? Okay, let's keep it up. Y prime here would turn into 6x to the 5th plus 1x to the 0. 1x to the 0 would just turn into 1. So it'd be 6x to the 5th plus 1. Does it make sense that the line y equals x has a slope of 1? Up 1 over 1. Up 1 over 1. Okay, here we go, peeps. Number 3. For 3, we got beautiful. Beautiful. Y prime on 4.
Negative 12x.
Oh, negative 12x, because this would be negative. This one is going to get me negative 4x to the 0, which is negative 4. When we have just a constant, the slope is always going to be 0. Number 5. 3x squared plus 2.
Yep.
Okay, let's keep it going. I thought we weren't going to struggle with that more than we did, so this is great. What about p prime on number 6? 3t squared. I love it. Keep going. Uh-huh. Yeah, that's it. The derivative of any constant, 0. The derivative of minus 5/3 t is 5/3 times 1, which is just 5/3 t to the 0. Just 5/3. I love it. How about this little beauty? Say it again. No, that's a good call. We could rewrite this as 1/3 x to the 3rd, and I didn't notice that this is not the derivative. This is just rewriting the original function. So what's going to happen when I bring that 3 out front? 3 times a 3rd? Or 3 over 3? Yeah, it's just going to be a 1. X to the, minus, that'd be minus 1x to the 0, which would just be minus 1. Awesome. 1997 AP test question. When this says find the derivative when x is negative 1, y'all, you cannot worry about that negative 1 yet. We need to go find the derivative with just respect to x before we can plug in any negative 1. But here's the deal. Can I do the power rule on this thing right now? No, because it's not just x to a power. It's 1 over x to a power. How could I rewrite that as x to a power? Yes, so if I were you, I would say this thing is the same as x to the negative 1. I'm going to write myself that little note. Okay, so now how your notation is going to be. F prime of x is what? Let's start. Derivative of this little ditty. Negative 3x squared. Love it, you guys. Plus the derivative of x.
Plus 1.
Yes, yes, yes. I saw people lipping this. This is good. The derivative of x to the negative 1. Negative 1 or negative x to the negative, take 1 away, to the negative 2, right? Yep, so it's always bring that exponent out front, take 1 away from the exponent, yeah? Now, are you ready to plug in a negative 1 to this? Gross, this is nasty. Let's go rewrite this so it's going to be easier for us to plug in a negative 1. I'm going to leave my negative 3x squared. I got plus 1. How do we rewrite this to help us plug in a value?
1 over x squared.
Minus 1 over x to the positive 2. This has got to go down. Yes, good job. All right. You guys, now I'm ready to plug in that negative 1, which seems excessive. Bob's going to try to cut those steps, y'all, and that's not going to work, Bob. You guys, now when they want f prime and negative 1, any x is going to get replaced with a negative 1. Replace this with the negative 1. Replace that with a negative 1. Be careful about the negative. So we'd have negative 3 times negative 1 squared plus 1 minus 1 over negative 1 squared. No calculator. No calculator. Do I do negative 3 times negative 1 first? PEMDAS says do my exponents first. Negative 1 squared, 1 times negative 3. Negative 3 plus 1 minus, what's this going to become? Very good. Yeah, minus 1, exactly, because he's saying we got negative squared is just going to get me a 1 here. So he said minus 1. Final answer. Negative 3? Yep. So that's what that will look like on an AP question. We're going to feel, I mean, guys, derivatives, we're going to be doing these like the back of our hand as we keep practicing these. We're going to do these a lot. Cool, cool, cool. Okay, let's look at number 8. Find the derivative when x is negative 2. Let's first go find y prime. Let's just go find the basics. Let's start with this guy. That would become beautiful. Negative 3x to the negative 4 minus 8x to the first, or just 8x, plus 1. The derivative of a constant 2, 0. Now, would I rewrite this before I'm going to plug in a value? For sure. If I don't have a calculator for this, I got to rewrite this. So I'm going to go rewrite that as what? How do I handle this thing without a negative exponent? Negative 3 over x to the 4th. I love it. Then we're going to go plug in our negative 2. Y prime of negative 2 means I got to go plug in a negative 2 at all of these x's. If you do not need to see this step, you don't have to show it to me. But could this be the final answer?
Yeah.
Yeah, you could just leave it there. But let's just practice. Negative 2 to the 4th. 2 times 2 is 4 times 2, 8 times 2, 16. So we've got negative 3/16 plus 16 plus 1. Is that right? Let's be done. Let's not finish that. We're done here. Just want to make sure that we felt good about this. Yeah. Okay, people. Here we go. Hoo-wee! How do I want to rewrite this so I can apply that power rule? Whoa, what root is this if there's nothing right here? What root is that? It's just a square root. So you guys, if I wanted to rewrite this, this would be minus 8 to the 3rd power square root. So if I want to get rid of that, it's power over root, 3rd power over the square root. So I'm just going to rewrite my g of x in case that helps anybody. We've got to go find this with respect to x first, you guys. What is g prime? What is the derivative of 1.2? A constant. Nothing. What's the derivative of 15x? 15. What's the derivative of minus 8x to the 3/2? You guys, we got to bring that 3/2 times that 8. So I'm going to write it right here. 8 times 3/2. How I like to think of this, what's 8 divided by 2? 4. 4 times 3? 12. 12x to the, what's 3/2 minus 1, or 3/2 minus 2/2? 1/2.
It's just a square root.
It's just a square root. I'm going to leave that there in case that helps anybody. Then they want the x's to replace with the 4. So I'm going to say, all right, the g prime of 4 would be 15 minus 12. And I'm going to write it like that, Coop. Square root of 4 instead of 4 to the 1/2, because that might help some people solve it. 4 to the 1/2 is the same as root 4. Root 4 is 2. 12 times 2? 15 minus 24? You got it. This is a lot. This is not just a power to an exponent being added or subtracted to a power to an exponent. We got division. But could I make this into just a power over to an exponent? Sorry, a variable to an exponent.
Yeah.
I could. Say it again, Beck. Oh, yeah. Well, we got to rewrite it as y before we can get to y prime. Yeah, my bad. Did I not give you an instruction? I sure didn't. Let's go find y prime. Okay, so on this one, first we got to rewrite y, y'all. What would this y become if I divide?
That would be 3x to the third.
Yes. What about this?
2 square root of x?
Not quite, because look what you did here. You did 5 minus 2 is 3. This exponent is currently a 1. So it would be plus 2x to the negative 1. Or you could have said 2 over x. 2 over x is the same as x to the 2x to the negative 1. But Ritz, I like that you wrote it this way because now it's in that power rule notation. How about this one then, you guys? If I'm dividing them by x squared, everything has to get divided by x squared. Minus 7 over x squared would be the same as minus 7x to the, yes. Now it's written in power rule notation. To Beck's point, he's like, what did you want me to do with this? Yeah, let's go find a y prime. Let's go find a y prime. That would get me. Yes. To the. Yes, sir. Bring that exponent out front. Take it down by 1. Ooh, plus 14 or minus 14? Plus 14. X to the negative 3. Let's keep it up, y'all. Oh, interesting. Do I really care about this? All right. This will just be good to get our juices flowing. If this is the derivative, what could my function have been? Whoa. Whoa. How do I undo what I just did? It would be x to the third. My function would be x to the third because is this derivative going to get me 3x squared?
No.
Yeah.
Well, yeah.
Bring that in front. We'd get 3x to the second. Whose derivative is x squared?
X squared.
Oopsies. Whose derivative is minus 2x? It'd be minus x squared. Oops-a-daisies. Whose derivative is 5? Yes. Yeah. So you guys, this is way, I'm not going to test you at all on this unit. This is just us thinking backwards. How about this, Diddy? Whoa. We can think about this. Isn't this the same as 1 over 2 x to the 1/2? Okay. Whose derivative would get me that? Look what we've done to each of these exponents. We've added 1. We've added 1. Isn't this the same as 1 over 2 x to the negative 1/2?
Yeah.
Okay. We added 1 to my exponents. So it'd become x to the, okay. What if I just left it like that? What would this derivative be? Bring your exponent out front and take 1 away. Okay, I'm just letting you know, everything we're doing through Christmas is derivatives, derivatives, derivatives. What you just did is an integral, and you did it backwards. An integral is just undoing a derivative, and we'll start that in January. This is just like a little dip your toe in it. Okay, let's not worry about that.
An integral is to the derivative as.
Okay, here we go. Oh, yeah. Okay. This is good. This is from an AP classroom question, but this is tough. Most in particularly, I think this K is making it harder. So if they said, hey, here's h of x, and they said determine K, wow. Okay. All right. We got this. Here's what I want us to do. If they gave us some info about the derivative, see that's f prime and that's h prime. Let's go find what is h prime. Let's do that. H prime with just respect to x. I'm not even going to put a value in there. K is a constant. So we've got 3k, and then we've got times f of x. You guys, that constant, she's just chilling. We got 3k. What's the derivative of f of x? Oh, cool. Okay, first I'm just going to write it as f prime, but I agree. I'm going to replace that with a 4/3 in a second. Minus, we got to rewrite this guy in the form so that I can take its derivative. This is currently minus 8x to the 1/2. What would that derivative become? Close, 1/2 times 8. Yep. If it was a 2, it'd be, yep. So 1/2 of 8 is 4. X to the negative 1/2. Good. Plus the derivative of g, I'm going to just say is g prime. Can we fill in some knowns here? Just like Harvey was doing. Harv, h prime of x, you agree it's just pi? Yeah. We're trying to solve for k, so I got 3k. You already told me f prime of x. You said, all right, that's just 4/3. Minus, oh, okay. How can I rewrite this so that my exponent is positive? Minus 4 over x to the 1/2. You guys, what is my x? X is 16. What? So it's really 16 to the 1/2 here, which is just the same as the square root of 16. Square root of 16 is 4. Wow. So we have 4 over 4, which is just 1. All right, I guess I'll do that in a second. Let's just go replace my last one. G prime of x. Negative 10. Okay, y'all. Now we're going to start solving. We got this. Pi equals. What's going to happen with my 3 times my 4/3?
Cancel out.
3's cancel, and I'm left with 4k minus
11.
Yeah, good call, because this would be 4 over 4, which is negative 1, plus negative 10 is minus 11. I dig it. We got to get k by itself.
And that just means it's, it'd be plus 11.
So pi plus 11 over 4.
Yep.
Whew. Okay, graphs are shown. H is f plus g. What's h prime of x? They didn't ask for any x in particular, did they? Oh yeah, this makes sense. Here we go. So you guys, we're going to say h prime of x would equal, we got to just go take these derivatives. So we're going to say f prime of x. If I'm taking the derivative, then I can add that to the g prime of x. What does f prime of x really stand for? F prime just means slope. You guys, can we go find the slope of this graph, which is f?
Yeah.
Slope is just rise over run. What's the slope of this f graph going to be? Yeah, I agree. So h prime of x is just going to be 1 plus g prime of x is just the slope of this g line. Rise over run. Rise over run. You got to find 2 points. I feel like there's a point. There's a point. What's my rise over run? I agree. Down 2 over 3. 1 minus 2/3. 3/3 minus 2/3. 1/3. You guys, what would a horizontal tangent mean? If the tangent's horizontal, all we're talking, derivative just means slope. What's my slope? 0. So if it ever says, hey, do we have any horizontal tangents? We want to know, does the slope equal 0? And what's fancy for slope? That just means derivative. So I'm going to say, when does my y prime equal 0? We got to go find my y prime. Let's go find my y prime first. What's my y prime? So let's go find that y prime. What's that y prime going to be?
2x cubed minus 18x.
2x cubed, because 1/2 of 4 is 2x to the 3rd minus 18x. Agreed. When does that slope, or my y prime, same thing, equal 0? So you guys, we're going to just go set that equal to 0. What are we factoring out of that? A 2x, yeah? What's left? Yes. Then he's saying I could do difference of squares there, and I'd get x plus 3 and x minus 3.
Yeah.
And when do each of those equal 0? When does 2x equal 0? When does x plus 3 equal 0? When does x minus 3 equal 0?
At 0.5.
0, because 0 divided by 2 is 0. And positive 3 and negative 3. So you had one of them, bud. We found the other 2 points. Awesome. I'm just going to, that one's just answered above.